Okay, so then the third symmetry that we're going to talk about is symmetry about the origin. Now, we say that a function or a graph is symmetric about the origin if for every point xy, the point negative x, negative y is also on the graph, then the graph is symmetric about the origin. Okay, so let's look at this function over here. This is the function y equals x cubed. And what do we notice? We notice that its behavior in the first quadrant is mirroring its behavior in the third quadrant. Okay. Also look at this. We have a point 2, 8, right? And so according to our definition, if a point 2, 8 was on the graph, the point -2, -8 should also be on the graph. And we see that it is. Okay. We can look at other points. We can look at this point over here, which is about -1, -1. And we can look at this point over here, 1, 1, which is also on the graph. Now, if I were to fold this graph, if I were to reflect this graph about the origin, then you would see that the graph would fall on itself. And so I can say that this graph is symmetric with respect to the origin. So how do we check for symmetry about the origin? So to check for symmetry, what we do is we replace the point xy by the point -x, -y. So replace xy by -x, -y. If the resulting equation is equivalent to the original equation, then we say that the graph is symmetric about the origin. So let's take an example. Okay, consider the function y equals x cubed minus x. Okay, so what I'm going to do now is I'm going to go ahead and replace y by -y. So replace y by -y and x by -x. So what I get is I get -y, right? I'm replacing y by -y equals -x cubed minus -x. Okay, so if I do that, I get -y equals, well, if I'm cubing a negative number, I'm going to get a cube, so it's -x cubed plus x. So, but I want to solve for y, right? So I'm going to multiply both sides by -1, and if I do that, I get y equals x cubed minus x. And we know that the equation that I started with and the equation that I ended with are the same, and so this is symmetric about the origin.